Global data volumes will grow 10 times over the next 5 years. Most of that data will reside on mobile devices or appliances or simply things connected to the internet. Now, if we extrapolate our current IT practices, the way that we design our data centers, the way we operate IT systems in the enterprise or on the cloud itself, we can see that a lot of that is wholly inefficient and is likely to create more impact on the environment, not less. Consider, for example, the use of mobile phones. In 2012, smart devices contributed to almost 6.5 million tons of CO2 emission. By 2015, that's likely to grow to almost 30 million tons. That's equivalent to close to 5 million new cars on the road each year. Clearly not a sustainable situation. All the data that we are producing is fundamentally changing the way we live our lives at work and at home. Now, cloud computing is the infrastructure that's providing a lot of that fabric for growth. But the key question really is cloud computing really green? Business demand, catalyzed by IT, is evolving at such a rapid rate, and it's making us consider many more options within the enterprise, whether it's purchasing IT systems in-house or moving a lot of those systems to cloud computing. So looking at that aggregated demand, looking at high utilization, and looking at greater efficiencies, one would think that cloud computing would be the natural option. But what are cloud computing's green credentials? So let's address that fundamental question. Is cloud computing green? For example, behind every virtual machine, there is a physical server drawing power from the electricity grid. Every bit of data consumes energy at its inception, creation, throughout its life cycle, and ultimately at its point of destruction. So there's a fundamental question here, is how do we actually manage that data? For example, do we need to have that data accessible 24 hours a day, 7 days a week? And what about the computing requirements, network, storage capacity that's truly needed to support that data that we're managing? Now, many view cloud computing as a bottomless pit, a resource pool that can effectively provide services on tap. But the engines and the supporting practices that drive cloud computing are far from being green. Many data center environments today and the servers they house are woefully inefficient. The rapid growth on these platforms will most certainly increase, not decrease, greenhouse gases. So cloud computing, energy consumption is a source of debate. On one side, some see massive new forms of industrialization in the cloud, consuming megawatts of power to feed insatiable demand, whether it's from social networking or from a range of mobile services. Others, however, hold the belief that the coming shift to cloud will reduce carbon emission footprints and also support that huge, massive increase in data. So where do we stand today? Well, we know, for example, that cloud computing is already consuming 1 to 2% of our global electricity supply. And that's on the basis of a fairly small density. But on a positive note, we start to see organizations bringing green IT together with overall IT strategies. And that's leading to better understanding of ways to reduce our dependence on power and looking at our carbon footprint. So for example, by 2020, in the US, for example, we see that moving to cloud and organizations that embrace green cloud technologies will save billions of dollars and reduce carbon emissions tremendously. So the question is, what is green cloud computing and how do we get there? So let's examine what is green cloud computing and how do we get there? Well, if you look at green IT and you look at cloud computing, you can see they intersect within the domain of enterprise architecture. By developing an enterprise cloud strategy, we can help organizations maximize business benefits through cloud computing while ensuring that IT services that are consumed are done so in a way that is sustainable and drives tangible green measures. Take, for example, the way that we develop applications. If we think about accelerating the whole innovation and leading to a point where certain functions, certain features, certain design elements can be pushed into a cloud environment, we can actually speed up the time it takes to develop a system and application, therefore reducing the burn rate and ultimately driving green benefits. Overall, though, looking at enterprise strategy around cloud examines both business and information systems architecture to determine if certain processes can be grouped together in terms of their consumption of data and underlying use of IT infrastructure resources. This will drive high utilization of enterprise resources on-premise and also determine which applications and data can be placed in a cloud environment based on a number of factors, such as looking at data security, looking at application performance in terms of the demand for storage, input-output, bandwidth, and compute power, looking at IT governance and risk management, looking at how processes themselves can be extended outside of the enterprise into a cloud landscape, looking at other aspects of how data is migrated, and of course, looking at the underlying regulatory and legal compliance frameworks. Now, when we look at enterprise strategies around cloud computing, we see that virtualization is the underlying fabric of cloud computing. There is, however, a misconception that virtualization is the driving force of cloud computing. It's not. Just building a virtual machine is not virtualization. Virtualization in itself is an architecture and has many touch points within the IT organization. For example, looking at how we virtualize services, whether they're on-premise or moving into the cloud, there is still the need to manage those services. Does our operating model allow us to do that? Do we have the skills? Have we trained resources to do that? In terms of looking at how we manage incidents, problems. How do we manage an environment that is not contained within the four walls of our enterprise anymore? How do we actually measure whether or not we are making improvements? How do we monitor that? How do we actually look at whether we're being efficient in the way that we're consuming energy? How do we measure our carbon footprint on applications that have been virtualized or sitting on infrastructure that's been virtualized? Fundamentally, virtualization will answer that question of whether cloud computing is green or not. Virtualization in itself is that insatiable power, if done correctly, will lead to tremendous benefits as we move into a cloud computing domain.